Hey guys, it's Omar. Okay, this is take two of me trying to attempt the website A/B testing lab. Before when I did it, I was like trying to record as I went through it, and I think that going forward, I'm just not going to do that. It makes more sense for me to actually get the thing done and then walk through what I did than trying to like talk as I do it because I keep bouncing around back and forth looking methods up, and it's just messier. It'll be less useful to you than just having me just cleanly walk through it quickly without too many sidetracks. So, okay. We have data on a website. Uh, there's okay, it keeps track of unique ID numbers of visitors and all the actions that they took. And there's two types of actions. They can either view or click or both, and they can belong to either the control group or the experimental group. So for the exploratory analysis, I when I was first doing this, I did a messy sort of back and forth exploration thing, and I just cleaned it up in this line of code. Let me just walk you through what this does. So we read in the data. And then right off the bat, I'm going to split it up into separate data frames, so the control and the experiment IDs, right? Then I have a function called process data frame through which each of these two, the control and the experiment, get passed. What this does is the first thing it does is it encodes dummies. So it'll take, the original data frame has just one column for action, and it can be either click or view. This one hot encodes them out so that if they clicked, it'll put a one. If they viewed, it put a one. And then the next thing it'll do is actually group them, group the IDs so that the IDs don't occur once and all the values associated with the IDs are just on one line. IDs never occurred more than once, or more than twice, I'm sorry. So the maximum number of times that an ID showed up was twice. And it was usually the case where they viewed and then they clicked as well. And that's when you got the ID more than once. And it was never more than twice. Um, but then by grouping it, we kind of aggregate together, all the data about them into one line. We're creating a new column to see if anybody clicked the website, right, but didn't view it, which would have been strange. And I couldn't find any cases of that happening, so that was a good thing. So then the next one is whether they viewed the website and then also clicked on it, which I think is more on point for what we're trying to do. And the second column that we create sort of puts in a Boolean value if that's the case. Like I said, we're going to pass both of the control and experiment data frames into it. So now when you come down here, you see that like click and view. So this ID number, they clicked, but then they viewed. The order of the columns is screwed up. I think this is a function of like which value it encounters first when it's like doing the one hot encoding or something, but it doesn't matter. So basically, if this ID viewed and then also clicked, this column will be true. Here they viewed, but they didn't click, so this column is false, and so on. So this is they viewed, they clicked, so it's true. And then all the way down the line. And then the same thing for the experimental data. So now we go down to conducting a statistical test. I honestly wasn't exactly sure what they wanted us to do. I just put a t-test because I couldn't think of what else to do. And I just put that in there. I had my reservations, and we'll find out what they do in the solution in a second when I open it. I haven't opened the solution yet. So again, caveat, I could be entirely wrong. Of course, that's something you should keep in mind every time you happen to watch one of these videos. I don't know if anyone even is, but if you are, just take them with a grain of salt, man, because I don't know, I could be wrong. Anyway, this is what I tried to do. And I got this weird p-value, I think, and it's not in line with what I get later on down the line. And later on, I tried to muddle through revisiting the section on binomial distributions and stuff and to try to do this part, okay? So here's what I do. All right, so what you're supposed to do is you represent hypothesis test to create a binary variable representing each individual in the experiment in the control group. The binary would represent whether or not that individual clicked on the home page, 1 for if they did and 0 for if they did not. The variance for the number of successes in a sample of a binomial variable with n observations is given by this. Okay. All right. Perform these, calculate the expected number of clicks if it has the same click-through as the control group. Calculate the number of standard deviations that the actual number of clicks was from this estimate. Finally, calculate a p-value. Okay, so here's what I do. Okay, so first what I do is I'm just going to sum up the number of times the control group clicked. Okay, and that's just like the sum of data frame control of click and view. And since that's a Boolean, that'll just add up. Each time it finds a true, it'll be 1. So this will basically sum up all the times that it clicked and they viewed. They viewed and they clicked. In theory, what I'm thinking is that since there was no instance where they clicked without viewing, you could just as easily just sum every time they clicked and you would ostensibly get the same number. But just to be safe, we did it that way. So that'll give us the number of times, the number of members in the control group who clicked after viewing, okay? And then the control mean is basically, that number divided by the length of all members in the control group. And that gives you the average number. That's the rate of clicks. So like out of every 100 people, 27 will click. That's what it came out to roughly. And we do the same thing for experiment. We take the sum, the number of times the experimental data frame, this column was true, meaning, add up all the individuals in the experimental group that viewed and then also clicked. And we divide by that by the length of the experimental column. So then we do expected clips, and I think this is how you would do it. I'm pretty sure this is how you would do it. You just multiply, expected number of clicks if it had the same click-through rate as the control group. So the idea is that if the experimental group was subject to the same rate of clicking as the control, then how many of those members would have ended up clicking, right? And that's simply a matter of like multiplying the mean of the control group by just the total number of individuals in the experimental data set, or like the n of like this number of IDs. I'm pretty sure that that's the right way to do it, but we'll see what the solution has to say. I could be wildly wrong on this. And we just print expected clicks, and it tells us that 838 people should have clicked. So now it says calculate the number of standard deviations that the actual number of clicks was from this estimate. Okay. And it says cont bar is equal. Okay, so what do I do here? Okay, so I get the variance of the control group. Okay, and I calculate that by multiplying the length of the control group multiplied by the mean and 1 minus the mean. I'm essentially implementing this formula to get that variance. And then I square root it to get the standard deviation. And then to get the z-score, what I did was I subtracted the expected mean from the control mean, and then I divided that by the control standard deviation divided by the square root of the length of the sample size. I don't know if this is right. Now that I think about it, I wonder if I should have done expected clicks minus. I wonder if that's because you're supposed to use that, right? And you're supposed to see how many standard deviations away was that from the other one. So I don't know. I honestly, I'm trying to wonder. Do I use it as fractions? I'm kind of lost here. I don't know. But so what I got was when I just calculated the z-score by multiplying the experimental mean from the control mean, was basically z, and then that's the z-score. Okay. So that's the number of standard deviations ostensibly from the mean that the new mean is. So that means that it's that much higher. And that, the number of expected clicks and the control clicks that's there. But that doesn't really mean anything because they're from different populations. So I think comparing ratios of that is a better idea, which I did. And basically the mean of the control group was like 10%. The mean of the experimental group was 10% higher than the control group, meaning the average number of people who clicked, right? So it was like 27% of the people in the control group clicked, and like 31% of the people in the experimental group clicked, which is like a rise of 10%. Is that in line with this z-score? Because I can't even say. I feel like I might probably just give in and look at the solution, but I gave it my best shot in a college try. And I don't know, if nothing else, maybe this is just helpful in seeing like how you would actually go about at least trying to solve this problem. So the p-value was 47. Basically, it's, it's 1 minus stats norm CDFZ. So we see, well, at this z-score, how many values have we encountered? And then we subtract that from 1 to get the p-value, which is the probability of observing the experimental mean from a distribution of the control mean. Does this match your previous statistical test? It does not. The p-value before was like, I don't even know, it was like 0.008. So I don't know what the hell's happening there. So I'm not even going to try to do an analysis. Let's just go over and like see what they have to say. Okay. 1 sample z-test. Okay. It's the last lab. I really just want to get this done so I can move to Bayesian statistics tomorrow. I'm done. I'm done with you. Let's look at the solution. Okay. What do they do? Pandas, NumPy, Matplotlib. Okay, they read it. They viewed it. So, okay. SIDS and VIDs. CIDs and VIDs. So here they looked at all the IDs. So okay, they split it up into 2 frames. One is all the ones where they clicked. One is all the ones where they viewed. Let's say number of viewers, number of clickers, number of viewers who didn't click, and then, okay, number of clickers who didn't view. That's 0. Okay, so that's good. Number of viewers, I think that also jives. Number of clickers, that also jives with what I got. Okay, everybody who clicked also viewed the home page. Yeah, okay, so I was right on that account. EIDs and CIDs, experimental and control. So now they're splitting it up that way. So they're going to just find all the set of unique IDs and the set of control IDs, and they're going to do the overlap of experimental and control, and that's 0. And I think that's also the case that's what I found. I did a lot of this nitpicky stuff, and then I just consolidated it into my master cell. Conducting a statistical test to determine whether the homepage is more effective. Okay, df count is equal to 1, df.head. Convert clicks into a binary variable on a user-by-user basis. I tried pivot first. That's interesting that they went with pivot, because I tried that and I did not have good success with it. Okay. Pivot. Index is equal to ID. Columns is equal to action. Values is equal to count. Interesting. That's how they did that. And then they filled NA with value 0. Okay. And then they do the same thing. So they still have 2. So it looks like they're doing 2 data frames. They're grouping by control and experiment, and then pivoting by action. I tried something like that the first time around, and it didn't work for me. So I switched to my method, which was, I don't even know what I did now. It'll be in the repo, guys. It's late. Okay, experiment fill in a print sample size, control size. Okay, so the sample size for them was this much. Seems right. That's kind of what I got too. Yeah, because see, I have 332 rows for my first, that's experiment. For I think experiment, yeah, that's control. Experiment, I don't even know. Okay. Yeah, but that's 2996. So that's good. Okay. Total clicks, I think I got a similar. If I go down here, I'll say, yeah, 928 for experimental clicks, 932 for control clicks. Okay, so that did that. All right. So they do a PS value Welch test. Is that it? Oh. Control.click and experiment.click. They pass in the click columns. So see, they ended up with the same thing that I did, right? Like, so you have the same thing. You have like ID and then 0 and 1. Okay. You know, so the clicks and views, and you can even look at the ID. So it's 182.994. Click as 1 and view as 1. I have the same thing here, right? Then they do a p-value Welch test using Flatiron Stats. Oh, because they imported the thing that we did before. I should have done I was thinking that I should do the Welch test because like the two populations have different sizes, and I don't know that they have the same variance. So yeah, I should have probably imported that and tried that. But still, I don't know. It's that. So now what are they doing? One sensible formulation, blah, blah, blah. So what are they doing down here? Okay, so when they do the manual sort of step-by-step thing. Okay. Calculate the number of expected clips for the experimental group. Let's see, 838, 838. So I was right there as well. I love being right. It's so fun. Super arrogant, I know. Calculate the number of standard deviations that the actual number of clicks was from this estimate. Here I fucked up. Here I messed up. Number of, okay. Import, okay. What am I doing wrong? So N is the length of the experiment. Okay, fair enough. P is the control rate. What the hell is the control rate? That's the mean. Yeah, okay. So that's the mean. That's the probability of, I call that Kant mean. Okay. Var is equal to N into P into 1 minus P. Isn't that what I do here? That's what I do here. Yeah, it's the length of, right? Okay. Oh, they use the length of the experiment. I thought, because I was looking at the formulas, and I feel like one of the definitions made me think, wait a second, should I be using the sample size as the N when I'm using when I'm trying to get the variance for this binomial distribution? So I'm going to do it. Let's see if that makes any difference in mine. I don't think it'll be enough. And I got like something like 25 for the standard deviation at some point. I don't know how. That's not a z-score. Is that a z-score? I don't know. Okay, hang on. No, I don't know. Print standard is equal to. Hang on. So let's see. So control STD. Let me print that. It's probably a bad choice of contraction. Okay, so I got the same standard deviation. Okay. Oh, I think I did this part wrong. Is that what I did wrong? Instead of dividing by that, I have to divide it by the control standard. So the z-score is actual experiment clicks minus expected experiment clicks. Oh, that's where I thought, that's where I messed up. That's what I was thinking, is because like I subtracted the experimental mean from the control mean. But then when I was doing that, I'm like, wait, that's not right, because they have different sample sizes and they're not like, that's not really, you can't measure one in terms of the other. That difference just means nothing. So I had my reservations, and I thought that's what it was. And so I'm glad that, okay. And then, so that would make sense. Okay. And then, so all you do is you get the difference of the expected versus the actual, and then how many standard deviations away is that? Okay. So I just applied the formulas a little wrong. This is why you really got to get the math down. So let's do that. So in my scenario, that would be experiment clicked minus expected clicks. Oh, and we want to divide this by the control standard deviation. We might as well, I think, because yeah, we're calling it control standard deviation, but really it should be the experimental standard deviation, but its variables are already there at this point. Okay, see now that, and that gets us, no wait, hang on. Oh, I didn't print Z, I'm sorry. It started raining here, guys. Yeah, I got the same Z, so that makes sense. So now let's just run this cell again. And I got the same p-value as they did, Finding okay, analysis. Does this roughly match that of the previous statistical test? Yes. While the p-value is slightly lower, both could lead to confident rejection of the null hypothesis. The experimental page appears to be a more effective design. What do you mean the experimental page? What is that? I don't know what that is. But I mean, I guess I see their point. Like, if the p is less than 5, it doesn't really matter by how much. But I mean, I want to take a closer look at the difference here. 0.004 versus 0.00012. I don't know, guys. That's a big difference in relative difference in p-values. And I guess if you tell me that's acceptable, that's acceptable. But I don't know. I mean, this difference is meaningless now, but I'm wondering if we're on a marginal scenario, which method do I choose? I don't know. One more thing for me to stress about, because there simply aren't enough things that one can be worrying about in life, I feel. All right, well, so that was that. That was fun. I hope that you found this video useful, and I'm going to bed because it is late. Bye.